Hello students, today we will learn the properties of inverse trigonometric function. Okay, so here in number 1 I have written sine inverse of sine x equals to x, which is very simple to remember. Okay, so we will look this property how it is working through this diagram here. Okay, so here as you can see I have written one function, that is sine function, whose domain is minus pi by 2 to pi by 2 and whose range or codomain is minus 1 to 1, since this is onto function. Okay, so now this sine function is taking this x to sine of x. Okay, now if I make the inverse of this sine function, then this sine inverse will take this sine x to its own pre-image. Okay, so that's why sine inverse of sine x is x. Okay, so similarly you can check this out, number 2, 3, 4, 5, 6. Okay, now in the second column, as you can see here, I have written number 1, sine of sine inverse x is also x. Okay, so for that I have made one diagram here. As you can see, there is a sine inverse function whose domain is minus 1 to 1 and whose codomain or range is minus pi by 2 to pi by 2. So this sine inverse function will take this x to sine inverse of x. Now if I make the inverse of this function, that is sine function, then this sine function will take the sine inverse x to its own pre-image, that is x. That's why sine of sine inverse x is also x. So similarly, number 2, 3, 4, 5, 6. You can take the screenshot of this page or you can just copy it in your formula book. Next we have a very important 6 properties from inverse trigonometric functions. So while solving the problems for inverse trigonometric functions, we will be using most of these equations. Okay, so here the property number 1 is sine inverse x plus cos inverse x equals to pi by 2. So let me prove this for you. Okay, so let sine inverse x equals to theta, then x will be sine theta. Okay, so this implies x equals to, now let us write sine theta in terms of cos. So we can write cos 90 minus theta, because 90 minus cos 90 minus theta is sine theta. So now if I operate both sides by cos inverse, then it will be cos inverse of x equals to pi by 2 minus theta. So this implies, so let us take this minus theta to left hand side. So it will be theta plus cos inverse of x equals to pi by 2. And since theta is sine inverse x, so sine inverse of x plus cos inverse of x equals to pi by 2, hence the result number 1. Okay, so similarly you can prove property number 2 and property number 3. Now let me show you this property number 4. There was a small mistake here. I had written only tan previously, so it's actually tan inverse. Okay, so tan inverse of x plus y over 1 minus xy. So let me prove this result for you. So here tan inverse of x plus tan inverse of y. Okay, so let me consider this angle as theta and this angle as phi. Therefore we will have theta equals to tan inverse of x, which implies tan theta equals to x, and phi equals to tan inverse of y, which gives tan phi equals to y. Okay, so now let me try to find the value of tan theta plus phi. So since we know the formula of tan theta plus phi from the trigonometry, it is tan theta plus tan phi over 1 minus tan theta into tan phi. So this implies tan of theta plus phi equals to, now since tan theta is x, so it will be x here, plus and tan phi is y, so it will be y over 1 minus x into y. Now if I operate both sides by tan inverse, then I will get theta plus phi equals to tan inverse x plus y by 1 minus xy. So this implies theta is tan inverse of x plus phi is tan inverse of y, which equals to tan inverse x plus y over 1 minus xy, hence the result number 4. Okay, so make sure to correct this portion. Okay, so I had written tan only previously, so it's actually tan inverse. So similarly you can prove property number 5 and 6. Next we have these properties. So here sine inverse of minus x is equal to minus sine inverse of x. So let me prove this number 1 for you. So let us consider theta equals to sine inverse of minus x. So if I operate both sides by sine, then it will be sine theta equals to minus x. So this implies minus sine theta equals to x. Now minus sine theta can be written as sine of minus theta equals to x. Now if I again operate both sides by sine inverse, then it will be minus theta equals to sine inverse of x. So this implies theta equals to minus sine inverse x. And since theta was sine inverse of minus x, then it will be sine inverse of minus x equal to minus sine inverse of x, hence the property number 1. Okay, so let me show you the property number 4 also. So here in property 4 you have cos inverse of minus x equals to pi minus cos inverse of x. So let cos inverse of minus x equals to theta, then minus x will be cos theta. So this implies x equals to minus cos theta. So this implies x equals to, now see, minus cos theta can be written as cos pi minus theta, because pi minus theta is in second quadrant, and in second quadrant cos is negative. So if I operate both sides by cos inverse, then it will be cos inverse of x equals to pi minus of theta. So here it will be theta equals to pi minus cos inverse of x. And since theta was cos inverse of minus x, so cos inverse of minus x equals to pi minus cos inverse of x, and hence the property number 4. So similarly you can prove property number 5 and 6. Next we have sine inverse of 1 over x equals to cosec inverse of x. So let theta equals to sine inverse of 1 by x. Then it will be sine theta equals to 1 by x. And as we know, sine theta is the inverse of cosec theta. So sine theta can be written as 1 over cosec theta equals to 1 by x. So that means cosec theta equals to x. This implies theta equals to cosec inverse of x. And since theta was sine inverse of 1 by x, so it equals to cosec inverse of x. So hence the property number 1. So similarly you can prove property number 2 and 3. So these were the properties which you have to remember. Okay, there are other properties also which I will discuss later.